Lastly, we look at having 6 electron domains. This electron geometry is called octahedral. There are bond angles of 90 degrees. So in our parent geometry, the thing that always confuses people is that we call it octahedral even though there are only 6 domains. The reason it's called octahedral is octa means 8, again hedron means faces, so there are 8 equal faces on this figure. 1, 2, 3, 4, 5, 6, 7, 8. So because each face is equal, notice I can put the same triangle over every single face, we call this an octahedron. And the bond angles for this are all 90 degrees. If we remove one bonding pair and replace it with a non-bonding pair, we get a geometry that we call square pyramidal. Notice since all of these domains are equal, it doesn't really matter which one we change into the non-bonding domain. The reason we call it square pyramidal is because that's a pyramid and the base is a square. The bond angles are 90 degrees, arguably slightly less than 90 degrees, since this non-bonding domain will compress the other bonding domains slightly. Next, if we take away 2 bonding domains, they come off on opposite sides so that they each have the most space. Since these want lots of space, we don't put them next to each other. Now this is called a square planar configuration. Again, if I remove these, you'll see that we have a square and it's flat. The rest, all of those atoms are in the same plane. This is the only way that you can get a square planar configuration. Even though you might draw a lot of different things in a square when you're drawing the Lewis structures, this is the only way to get a square planar molecular geometry. In this case, the bond angles are exactly 90 degrees again, because you have equal compression from both sides. This lone pair is pushing them that way, this lone pair is pushing them that way, and they balance each other out. If we have 3 bonding domains and 3 non-bonding domains, now we have to put lone pairs next to each other. This one becomes T-shaped, 90-degree bond angles. Again, arguably slightly less than 90 as these compress down a little bit. And if we have 2 bonding domains and 4 non-bonding domains, now this geometry is going to be linear. All of the ones around the middle have been removed, and we're left with 3 atoms arranged in a straight line, 180-degree bond angles.